Okay, for the second week, we're going to concentrate on the science part of chapter one. What is science? What is the scientific method? How does science differ from other ways of thinking and learning about the world? And so we're going to talk about science and the scientific method. We'll talk about different types of science, discovery science versus experimental science. We'll talk about how scientists evaluate ideas and the steps in the method. And so here I have two little things. The top one is a word map on science, and the bottom one is a Venn diagram, kind of a simple concept map. You don't have to memorize them. They're just kind of showing you kind of what is science. And so, what is science? Okay, science is the systematic study of the natural world. Could be any part of the natural world. Could be outer space. Could be chemistry, physics. It could be people, and so we're part of the natural world, and so scientists might study us. And scientists, you might think they're not normal people, but they really are, and they're just engaged in this process of finding out about the world, and it's the systematic nature that makes this very important, and that it's kind of a democratic process has really made it quite quite useful and uh, very advantageous. Not all science is the same, and much science is what's sometimes called discovery science. It's just describing the world, kind of observations of things that are. Um, Lots of science is in biology. We take scientists go to new places and they try and see what organisms are there. They take samples and just see what's there. It's observations, or sometimes it's making measurements. And then when we have these new observations and new measurements, we classify things. Okay, that's a big part of science, kind of just describing stuff. And as technology improves, we're always doing this, and these new observations and new measurements lead to new questions and new ideas. Here, this is a picture here of the Hubble Space Telescope, the upper diagram. It kind of looks like a double-decker garbage can, but that was the first telescope outside the Earth's atmosphere, and so it led to lots of new observations. Here's a ground-based picture on the left of a galaxy. Here's a picture taken with the Hubble Space Telescope, and we can just see more details, and so that leads us to having a better description of the world and all sorts of new questions. Okay, when we have new questions, we often answer those with experimental science, and here's where the scientific method comes into play. How do we evaluate ideas and answer questions about the world? Questions like how and why. Well, we find out what observations have already been made, what people have already thought. These are kind of researching, and then we think of our ideas and we try and plan in experiments to answer questions. We collect new information, new evidence, and hopefully that evidence can help us come to a conclusion. And this is shown as, often we learn about this in our first science course as it's step one, step two, step three, but it's not really like that. Usually we start with observations, and that leads us to questions, but you don't always get the right answer quickly. It often comes very slowly. And often there's more than one possible answer. And in science, instead of finding evidence to support the answer that you like, what you really do is you try and eliminate wrong guesses. You find experiments that give you evidence that help you discard wrong hypotheses. And so often you're doing a series of experiments to reject ideas that are wrong. And the best ideas are the ones that have some evidence for them, no evidence against them, and they make predictions that you can confirm. So they give you ways of looking for new information that help you verify that idea and prove the others that are wrong. So I'll give you one example. So as a kid, I loved dinosaurs, and when I was a kid, there was a big question: how did the dinosaurs disappear? and there were lots of ideas. And these ideas, in science we call them hypotheses, but they're just ideas. They included that the mammals ate their eggs, a great disease came and wiped out the dinosaurs, or the climates changed, or there were volcanoes, or when I was growing up, the new idea was that there was an asteroid impact that wiped them out. And so there was lots of ideas, but how do you test these and how do you find evidence? Well, that's hard when you're talking about something that happened 60 million years ago and there's no dinosaurs there now. We want to find testable ideas that make specific predictions. And so that's the key in science, is to evaluate the ideas. And with the dinosaurs, we can't find a time machine, but we can look for new evidence. And so we go to the fossil record, we start looking at layers of rocks to see what ideas best support what we see. And so as we look more and more at these layers right when the dinosaurs disappear, what we find is that there's a very abrupt extinction. It happened almost right away. And the one idea predicted that there would be a large crater. In fact, one of the largest craters known on Earth is found and dates exactly to that time. And worldwide, you can find right at that time a layer of rock that's very thin, and this contains the metal iridium. And this metal iridium is common in asteroids, but not common on the Earth's surface. But there's iridium in this thin layer worldwide. There's also, near this crater, there's a huge amount of jumbled sediments, as if there was a giant tidal wave, and then what are called shock quartz and iridium. So these are found in this layer. So that's a picture of shock quartz on the lower right there. Next to it is a gravity map of the crater. It's just off the coast of the Yucatan Peninsula. Then you can see the sediments there showing the iridium layer. And we've even got some fossils that we think were deposited on the day of the extinction, because we have shocked quartz and things called tektites in their gills. And so a really kind of neat thing. And so this is a way to get evidence. We don't conduct necessarily experiments in the lab, but we collect new evidence. And so that's really the key with science. So to summarize, science is the systematic study of the natural world. Scientists make observations and describe the natural world, and they evaluate alternative ideas by testing their predictions and comparing those predictions to what evidence they have. Okay, I have one more little program on science that deals more with people, and so check that out.